All right. Now that we've dealt with the theory of the mole and know that a mole is a quantity of atoms equivalent to 6.02 times 10 to the 23rd, and that quantity of atoms then will cause us to have the AMUs change to grams. We need a periodic table for this today, and we need a calculator. So if you don't have a calculator, pause this, and then we will continue on, because there's a lot of calculator work for this section and the next section. All right. The problem that we have here is that we never get one of anything. And everything we've done so far is 1 mole of this, 1 mole of that, how many atoms, how many grams for 1 mole. But we normally don't just get 1 mole. Life is messy. Life is ugly. Life does not give us nice, neat whole numbers, unlike what we were talking arithmetic and in math. Everything comes out nice and neat. It's usually pretty nasty fractions and decimals and large numbers and small numbers. We got to deal with it all. So this is why the calculator is so important for us. So, and when we talk about chemistry, it's just as bad. So let's suppose we have 2.5 moles for antimony. And I want to know how many atoms is this and what is the mass. So 2.5 moles of antimony. Antimony is Sb. Okay, so we find Sb on the periodic table, and Sb is element number 51, so put 51 down here to remind us of this. And so we're trying to find two things. This is equal to how many moles, and is equal to how many grams. These are the two problems we're going to have to deal with here. So these are conversion problems. Like I said when we dealt with conversion, in the previous chapter, we're never done with them. We're always using conversions. So we start with what we're given here, 2.50 moles of Sb times fraction line. All right, you get rid of the moles and oh, I don't want moles, I want atoms here. Sorry, that's wrong. There should be atoms up here. So since we want to get rid of the moles, we put moles down here, and we want to go to atoms here. We now have a conversion, and the conversion that we're going to use, we know that 1 mole means exactly 6.02 times 10 to the 23rd. So we'll put a 1 by the mole, and 6.02 times 10 to the 23rd. So on your calculator, go ahead and punch that in. And when you do that, you get an answer of somewhere around here. Where did it go? Oh, yes. This is 1.505. Yeah, 1.505 times 1.505 times 10 to the 24th. We round that off to 1.51 because, again, we want 3 significant figures in everything we do. Now, your calculator is going to give you 1.51 E24. Now, we talked about this in the scientific notation chapter or section, and remember that the EE key or the E symbol here is not a legitimate mathematical representation of a number. It is a simplified form that needs to be redone into this scientific notation form. Okay, so please be sure that you have that figured out. And the 1.505 that is given to you is 4 significant figures. So you have 1, 2, 3. The 0 here is your third significant figure. You have a 5 exit, so it's got to kick it up to a 1.51. Next thing we're going to do is we're going to change the 2.50 moles to grams. 2.50 moles of Sb times, and then again put 1 mole at the bottom. Now that we're talking about grams, we're no longer dealing with the number 6.02 times 10 to the 23rd in the problem. It's in the background that causes these AMUs to become grams, but we don't put it into this problem. So we find SBM 51 and round it off 3 sig figs. It says 121.760. So the 121, and then there's a 7 after that. We got to kick it up to 122. That becomes 122 grams per mole. And again, these are both on top, just like these were here, so they're multiplied 2.5 times 122. And we get for an answer 305 grams of antimony. Okay, so that's how we go from moles, different number of moles, up to either atoms of a substance or grams of a substance. Now, let's go the other direction. Let's start with a number of grams or a number of atoms and go back and see how many moles we actually have. So let's suppose we have 200 grams of oxygen. So 200 grams of oxygen. And I want to know how many moles of oxygen this is. All right, so this is again still a conversion problem. 200 grams of oxygen times fraction line. And we put grams on the bottom, cancel that out, and we want to end up with moles. So we go to the periodic table. Periodic table, this is always 1 mole, every time, 1 mole, because we change all these to the number of grams per 1 mole. So this will always be 1. And oxygen, round up 3 sig figs, 15.9994. So 15.9, the first 9 is the third sig fig. The 9 after that is going to kick it up to the next higher 1. So the number after 159 is 160, with the decimal point back in there. And that becomes 16.0. Do not put 16 there. I want 3 significant figures in all your numbers, including the rounded off numbers. So don't say 16. That will not be completely correct. 16.0 is what I'm looking for. So you take 200 divided by 16.0 on your calculator. This one I can do in my head. Is 12.5 moles. Okay, so that's how we work backwards to it. Again, the conversion problems make it really, really simple. When you deal with the labels first, then put your numbers in. You can't help but get a right answer unless you've got cramps in your fingers and you can't type correctly in your calculators. Okay? All right. Next problem. We're going to go from number of atoms. So here, let's suppose we have 7.00 times 10 to the 22nd atoms of thallium, and I want to know how many moles of thallium I've got. All right? So again, conversion problem. 7.00 times 10 to the 22nd atoms of thallium. And I want to know how many moles of thallium that is. Well, thallium is element number 81, so no, we don't even need that anymore because there is no mass involved in this. We just want the number of atoms here. So we start with 7.00 times 10 to the 22nd atoms of thallium times fraction line. Now, we're going to put the atoms on the bottom, moles on top. And again, the conversion always involves 1 mole, so we put 1 mole here. And the number of atoms, by definition, according to Avogadro, and this Avogadro's number is 6.02 times 10 to the 23rd. Cancel out if you want, just to show that you left with moles. We have an issue here. We got to be careful. And here's the issue. Your calculators are not as smart as you think they are. They will do exactly what you tell them to do. If you type this in your calculator like this, 7.00 times 10 to the 22nd divided by 6.02 times 10 to the 23rd, The calculator is not a mind reader. The calculator does not understand what you want it to do unless it fixes itself before it's done, which I'll talk about. But in this case, if you take a look, the order of operations tell you that if you've got multiplication and division, it's going to do it in the order it comes if they're all part of that family of operations. Well, they are. So this calculator is thinking, you want to take this number here, you want to divide it by 6.02, and then you're going to take that answer, multiply by 10 to the 23rd, you're going to get an answer 10 to the 46th power. No. Look, 10 to the 22nd divided by 10 to the 23rd, if you know your rules of powers or exponents that are being divided, you subtract the exponents. 22 minus 23 is negative 1, not 45. So we're going to have to do something different. Well, one way, if you prefer to write your problems like this, is that you must put the whole thing in parentheses. Then the calculator follows the rules of operation by doing the parentheses first, and then dividing that into 7.022 times, or 7.0 times 10 to the 22nd. Another way, and we talked about this when we talked about scientific notation, is that you can go ahead and type in 7.00, but instead of putting times 10 and then hitting the caret to 22, for those of you who have the graphing calculators, the rest of you will probably have to do this. Now, if you do this, you don't have to put parentheses here because it's multiplying, but it might be a good idea to get in the habit of always separate your numbers just in case, okay? It won't change, but just getting the habit of putting parentheses helps you not make this mistake of not putting in there. Anyway, get back to this. Remember on your graphing calculator, you have a comma key on the left-hand side, and in yellow or green above it, it says capital E, capital E. Hit the second and then that, and you get a small capital E placed right there. That is times 10 and caret. Then you just put in 22. You don't need parentheses, because that's the other part of this character E, is that it's assumed that it's all one number, not separable like this one was. Then you hit divided by, actually they'll look like this. And then 6.02, EE 23. And again, you will not need parentheses for that because the EE puts an imaginary parentheses in the whole thing. It just saves you like 5 different things you have to punch in by doing it this way. All right? So then when you type that out and calculate it, you get an answer that I did not put in here. Oh no! Okay. Well, I will make sure to get that in there for your script when you get it. But if we go ahead and go back over there and do the calculation for that. So this is going to be 7EE 22 divided by 6.02 second EE 23. We'll get 0.116 round off to 3 feet. And the label for this is moles. So 0.116 moles. Okay? All right. So, your practice problems. You got 8 of them. 4 involving changing moles to atoms and moles to grams. And then the last 2 going from grams to moles and then atoms to moles. So we got 2 of every type of problem that we talked about. All right? Good luck.